Yes, from the chapter Work and Energy, we are going to do the concept of the work today, children. The concept of the work is very important in science. In science, particularly in physics, we talk about work. Now, what is work? It means that in common ways, we say that any activity, it can be physical or mental activity. But in physics, it is not so. So, what is work in physics? There is a lot of difference between the definition of the work in physics, in day-to-day life, as well as in scientific terms. Now, you can see that, yes, you can see everybody from the figure, just see to it. In the first figure, the girl is reading continuously for some hours. The boy is writing or drawing, so many things he is doing from the morning till evening. This boy is standing and he is thinking something from so many hours. The boy is sitting on the cycle and he is trying to move, but he is still there on the cycle. According to we people or you people, we say that the children are doing lot of work. The girl is reading from morning till evening, so lot of hard work is being done by all of them. It is really they are doing hard work, but in scientific terms, they are doing very little work. In scientific meaning, we don't consider this work as the work to be done. Now, for example, you have a rock and you try to push it and you are not able to push it. You have applied entire force on it. Have you done the work? According to us, we have done lot of work in pushing it, but we are not able to push it. Similarly, you can see in the figure, you can see in the next figure, see, there is a boy. What he is doing? He is applying force on this Almira. See, the force is being applied, but the Almira is not moving. His entire work, what he is doing, is not used. Whatever force is applying is waste because the Almira is not moving. In the second figure, you can see that there is a lady who is standing and pushing the trolley. Earlier, she was on this position, you can see. Now, when she she pushed the trolley, she covered some distance and she moved to this position. You can see the figure and she covered X distance. It means she has done the work in pushing the trolley. So what do we say? All hard work that you are doing here in the first figure, that is in day-to-day life, you are doing all efforts. That is in just reading or writing or just thinking or holding something for some hours. That is not a scientific meaning of the work. Scientific meaning of work is only in this figure. You can see the lady who is applying a force on this trolley and the trolley is being pushed to a distance. Then we say the work is done. Again come to the previous figure. Then when we have said the work done here, there is force is being applied, but the displacement is not there. The object is not moving from its position. Then we say the work is not done, zero work done, because force is applied, but displacement is not there. In the second case, you can see the force is applied and the displacement is also there, that is x meters. That means the work done is equals to force into displacement. So we say that the work will be done only when the force is applied on the object and it shows displacement. And if force is applied and displacement is not there, like in the previous figure, no work will be done. If both the things are there, then we say the work has been done. Now see this figure again. Now one more figure, see to it. The person is applying a force on this box. He is applying a force and the box has moved to certain distance. When it has moved to certain distance, it means the work has been done. It means work has been done in a scientific manner. So what do we say? What are the two conditions for the work to be done? We say that work can be done only under two conditions: if the force is applied and it shows displacement. It covers to certain distance. Okay, children. Now again, now when we are saying that the two conditions are force should be applied and distance should be there, then only the work has been done. And if any only one condition is satisfied, we will say no work has been done. We say no work has been done. So we say that work is defined as the force acting on the object and it produces the displacement of the object. Then the work is done. Now children, I am using the word displacement because when the object travels in a straight line, distance and displacement all are both are same. You can, the distance and displacement are same whenever the object travels in a straight line. Now, for example, if I ask you, if the displacement occurs in the direction of the force applied, then also the work is done. And if the displacement occurs in the direction opposite to the direction of the force, then also a force applied, then also the work is done. Work can be done in both the ways, whether the object is moving in the direction of the applied force or it is moving in the direction opposite to the direction of applied force. You can see here, said work done is equals to the product of force and displacement. It means that work can be done only when the force is applied and its object shows displacement. For example, the girl is pulling, the boy you can see in a figure, he is pushing a trolley. He is applying force on the car. What do you say? Is he doing the work? Yes, he is doing the work. He is doing the work. What work is doing? That he is applying the force on the trolley and it is covering a distance d, you can see. So both the conditions are satisfied here. The force is being applied on the trolley, on the car, and it is showing displacement. Both the conditions for the work to be done are satisfied here. Now you can see one more figure, that here the person is standing. He is having a bag in his hand and he is applying force on it to hold it. But he is not moving. He is standing at a place. So in this case, the displacement or the distance is 0. So what do we say? Will there be any work done by the person? No. No work will be done by him because the displacement is 0. He has not covered any distance. Now in the second case, what do you see? The person has started moving. He has started displacing himself. He has covered a distance d. Here the work is done or not? Yes, the work is done. So we say that work will be done only when the force is applied on the object and the object shows displacement. And if any one of the condition is not satisfied, we say no work will be done. I am giving you the example. For example, I have a book in my hand. I am holding it in my hand for hours. So in that case, I have not done any work because I am holding the book. The book is applying force on me, but I have not displaced this book from my position. But if I displace this book from this position to a height, then I have done the work. Means both the conditions are satisfied. The force is applied and the displacement is there, you can see, and the work has been done over here. Now, so many examples are there. If the girl is pulling a trolley and the trolley moves in the direction of the applying force, we say that the work has been done. Okay, similarly, if you have a football, okay, the boy applies a force on it and the football moves to a long distance. What do we say? We say the work has been done because both the conditions are fulfilled over here. The force is applied and the displacement is also there. Now come to next, that the work done. What is the unit of work done? How to find the unit of work done? And is it a scalar or a vector quantity? Now you can see work done. What is work done? It is the product of force and displacement. In the figure, you can see force. What is force? What is the unit of force? The unit of force is Newton. Okay. And displacement is what? The unit of displacement is meters. It means work is equals to Newton meter. So the unit of work is Newton meter. We say that when 1 Newton of force is applied and the object displaces by 1 meter in the direction of applied force, we say that it is equals to 1 joule. It is equals to 1 joule. So joule is the unit of the work done. Joule is the unit of work done. We say that 1 joule of work is equals to 1 Newton of force into 1 meter of distance. Again, I am reminding you that you should know that how to find the unit of the work, that is joule, or how to define joule as. Okay. Now, one important thing. Now, the work is a scalar or a vector quantity. We should know about it. What is a scalar quantity? Say scalar quantity, yes, it has a magnitude only. And what about the vector, which has magnitude as well as direction? Now see everybody, children, that force is a vector quantity and displacement is also a vector quantity, and both of them together, the work is a scalar quantity. Now you will think that how it has come, that force is vector, displacement is vector, and ma'am is saying the work is a scalar quantity. Work is a scalar quantity. This you will read in 11th class. When you will go, you will read that what is the product of two vector quantities. What is the dot product of two vector quantities when you read out. Okay. So now children, we have come to know that the unit of work done is what? It is joule. Now if I ask you that if we say that if an object applies a force of 5 newtons and it displaces by 6 meters, what will be the work done? Yes, yes, it is 30 joules. Very right. You are correct. It will be 30 joules. Clear, children? Yes.